Hi, everybody. We've had a few questions from my webinar the other night, and I'm going to do my best to answer them. So what is superoxide? Superoxide is a charged up oxygen molecule. It is O2 minus, so it's got an extra electron. So it is a free radical. So this superoxide is critical in killing pathogens. However, too much of it can cause damage. It's a signaling molecule for apoptosis, aging, senescence. But it gets toxic at high concentrations. So because it can inactivate enzymes, increase lipid peroxidation, damage the iron sulfur clusters, which actually increases DNA damage. It liberates iron, so it increases iron dysregulation, which increases oxidative stress. It increases the indiscriminate free radicals, the hydroxyl radical, the Fe3+, the Fenton reaction. So it is regulated by SOD, superoxide dismutase. So it is a necessary molecule. However, too much of it can cause damage. And we've got three main ways we increase superoxide in the body. One is through uncoupled NOS, nitric oxide synthase. When NOS is uncoupled, it becomes a superoxide generator, not a nitric oxide generator. And BH4 tetrahydrobiopterin is what keeps NOS coupled. Superoxide is increased by NADPH oxidase enzyme. And this NADPH oxidase enzyme is another way our body defends ourselves against pathogens. However, there's so many things that upregulate NADPH oxidase. And an uncoupled electron transport chain increases superoxide. But the beautiful thing about supporting the nitrate to nitrite to nitric oxide pathway is this inhibits the production of superoxide through all of those pathways. So can nitric oxide lower cholesterol? Well, nitric oxide can decrease triglycerides, and it actually can decrease plaque formation in the blood vessels. How does nitric oxide cause vasodilation? Well, nitric oxide increases the activity of an enzyme called cyclic GMP. This cyclic GMP relaxes the smooth muscles around the blood vessels to increase vasodilation in the circulation and the microcirculation. And it's so important in the microcirculation because this is where all exchange takes place. Your oxygen, glucose, nutrients, and just as importantly, cleaning away the cellular debris. Nitric oxide is essential for erectile dysfunction. So ED equals ED. Erectile dysfunction equals endothelial dysfunction. Endothelial dysfunction is a nitric oxide deficient state. So you can't get an erection without adequate nitric oxide. All of these PDE5 inhibitors like Viagra, Cialis, these work on allowing that nitric oxide to hang around longer, but they will not work without adequate nitric oxide to begin with. So that's why these drugs don't work in about 50% of the people. So supporting the nitric oxide production supports circulation, microcirculation, decreases these needs for the PDE5 inhibitors. Nitric oxide and neuropathy. Neuropathy is caused by a couple different things, but mostly diabetic neuropathy. So when you have diabetes, what happens to you is your circulation and microcirculation become impaired. It's a nitric oxide deficient state. And so when the microcirculation is impaired, these cells can't be fed oxygen, glucose, and nutrients. Cells can be no more than 2 cells away from a microcapillary. And if that microcapillary isn't open and feeding this cell, it dies. And that includes the nerve cells. And so this creates cellular debris, which can increase these pressure on these nerves, causing the pain. By optimizing nitric oxide, this will decrease neuropathy. Nitric oxide will lower blood pressure. The nitric oxide governs circulation and microcirculation. And most of the drugs that are on the market actually involve increasing nitric oxide in one way or another to decrease blood pressure. Nitric oxide is essential in brain function. So high blood pressure precedes dementia. And about 50% of us actually have high blood pressure. And this hypertension precedes dementia even by 10, 15 years. The brain has 2% of the body mass, but it consumes about 20% of the body's oxygen requirements. And so if that circulation and microcirculation is impaired, those cells are not receiving the oxygen. The brain produces, well, it should produce about 20 times more nitric oxide than the rest of the vasculature all together. So when you have impaired nitric oxide production, you have impaired cognitive function. Cortisol decreases nitric oxide production. Cortisol uncouples that NOS enzyme. When NOS is uncoupled, it increases superoxide production. Superoxide production decreases nitric oxide production even more. By cortisol impairing nitric oxide production through the iNOS, the inducible NOS, this impairs our immune response. This is why when we're stressed, we get sick easier. By impairing the eNOS, the endothelial NOS, this increases cardiovascular issues, increases hypertension, MIs, strokes. So cortisol is increased by nitric oxide deficiency. The adrenals require adequate nitric oxide in order to function correctly. And cortisol impairs nitric oxide production through numerous pathways. Anxiety is nitric oxide mediated. So nitric oxide mediates BDNF, which plays a part in anxiety and depression. So nitric oxide increases neurogenesis, helps rebuild the neurons. Nitric oxide also increases the activity of an enzyme called GABA transaminase. So this allows GABA to hang around in the brain longer. And GABA is our inhibitory neurotransmitter. So it decreases the excitability from NMDA excitation, from the excitation from calcium influx that we get from EMFs. Nitric oxide decreases that. The symptoms of low nitric oxide are throughout the gamut. Nitric oxide touches every single physiological process. So without nitric oxide, you have impaired circulation and microcirculation. Nothing functions correctly. With low nitric oxide, healing cannot and will not take place. So not only will you have hypertension, increased cardiovascular disease, increased metabolic disorders, diabetes, insulin resistance. You'll have sexual dysfunction in both men and women. Nitric oxide governs mitochondrial biogenesis and the health of the mitochondria. So with depleted nitric oxide, your mitochondria are not functioning correctly. They are making more superoxide, uncoupling that electron transport chain. So there's not one process in our body that is not touched by low nitric oxide. Nitric oxide decreases these inflammatory cytokines, inflammatory chemokines, inflammatory interleukins, platelet activating factors. So nitric oxide decreases that inflammatory response. And this is very critical in today's viral climate, because what this virus does is increase these inflammatory cytokines. Nitric oxide decreases the inflammasome NLRP3, which then decreases all these inflammatory reactions. Nitric oxide decreases the mast cell degranulation, the histamine release. And we all know like what our brain feels like when our allergies are increased. We don't think well. Nitric oxide plays a role in that. So inflammatory cytokines can increase the production of nitric oxide through the iNOS, the inducible NOS. However, remember I said superoxide and oxidative stress uncouple that NOS enzyme, including iNOS. And when iNOS is upregulated, actually you're using up more of that BH4, the tetrahydrobiopterin. You're oxidizing this to make BH2, which uncouples the NOS even more. So with continued stimulation of the iNOS, you're actually uncoupling that NOS. You're not making as much nitric oxide. By stimulating iNOS, you're actually increasing the superoxide, increasing oxidative stress. So by supporting that nitrate to nitrite to nitric oxide pathway, you are increasing the production of BH4 to recouple that NOS enzyme, increasing nitric oxide, decreasing oxidative stress. You are inhibiting that enzyme NADPH oxidase, whose only job is to make superoxide. You are recoupling that electron transport chain, decreasing the superoxide production. So supporting that nitrate to nitric oxide pathway is not only increasing nitric oxide, but you're decreasing oxidative stress. And this pathway is so critical because by the time we're 40, this NOS pathway only functions about 50%. And by the time we're 60, it's only functioning about 15%. So supporting that nitrate to nitric oxide pathway is critical in healthy longevity. Cardiovascular disease is still the #1 killer in the United States. So supporting that pathway is essential for everything in our body, for every single physiological process. So thank you. Thank you for watching the webinar, and thank you for tuning in for the question and answers.